All right. Hello, folks, and welcome to another edition of The Binding Status. I'm your host, Dan here. I am an engineer on the Crossplane project, and I work at Upbound and do some Kubernetes-related upstream things. And today, we're going to have an awesome episode with Knative. Matt Moore is joining me on this call, so we're really excited to have him. So Matt is a maintainer, founder, TOC member for the Knative project. He specifically works on the serving side of Knative, which we'll be talking about in a little bit, kind of the distinction there between serving and eventing. But before we get too far into anything, Matt, I just want to give you an opportunity to kind of introduce yourself and tell us anything that's going on with your life or what you're working on and what you're interested in.
Yeah, so I'm Matt Moore. I'm one of the folks who started Knative while I was at Google. Yeah, I mainly focus on serving these days. And when the project was getting started, I had a hand in some of the build stuff that's now sort of moved out of the Knative umbrella and is now what many folks, it's this now called Tecton. And that's prior to starting Knative, I spent a lot of time in the container tool space. And so that was sort of a fun transition where I had a foot in both worlds for a little while. So, but yeah, these days I focus on serving.
Awesome. I appreciate the intro, and we definitely appreciate you taking the time on a Friday to hang out with us and everyone in the chat. And speaking of the chat, I wanted to go ahead and give some shout outs. It looks like Steven is joining from Florida. Steven does some work on Crossplane. Jared joining from San Diego. He's one of the founders of the project. Mocha is joining this week from San Francisco. If you all follow the Crossplane Twitter feed, she'll probably have some live tweets coming out while we're going through some different things in this, so feel free to check that out. Phil joining from Seattle. Looks like the Upbound account is joining from WW, which I assume is Washington or Seattle, or West Washington maybe, because it looks like Michael might be doing that. So yeah, we've got some good folks on here. As you continue to join, please feel free to introduce yourself and we can give you a shout out. And also as we're going along through the show, feel free to drop comments, questions, etc. And we'll circle back around regularly and try to get to those. So before we jump into some of the documentation, because we want to kind of give some background on Knative, folks who have watched the show before are probably somewhat familiar with Crossplane. And they, likely because Knative is a popular project, they've heard about it or used it before. But Matt, I wanted to get kind of your personal take on what the kind of mission and vision of the project is and maybe how it's grown over time.
Sure. So when we were starting Knative, the sort of mission that we had in our mind, and this has evolved a little bit over time as the scope of Knative has adapted, like I mentioned, build moving on, was to effectively try and look at what folks think of as your sort of traditional serverless experience, right? So your Lambdas, your app engines, your et cetera. There's a whole bunch of them. I won't list them all. And figure out how we bring that to Kubernetes, right? Because Kubernetes is becoming increasingly ubiquitous. And so as a common sort of target for those kinds of experiences, right, we wanted to figure out how we enabled serverless on top of that. And so there were, when I think of sort of traditional serverless, it's typically source-based, right? I take my function or my service or whatever, and I typically send the code over. That's, well, we don't want to talk about how it works yet, but that's then run in a way where I'm build based on my usage, and it scales up. It scales typically to nothing when I'm not getting usage, and then popularized by Lambda. A lot of that usage is event driven, right? So I get to take my code and have it run when certain events fire, right? And that's a really powerful model. But we were looking at that, and there's sort of three areas we identified that we felt like there were gaps that needed to be filled, but that, it didn't necessarily have to be one big thing that like tried to address all three of those problems. So when we started, there were three projects. There was build, which handled taking the source and turning it into a container. There's serving, that basically tried to do that usage-based scaling. And there was eventing, which is trying to develop a model where you can, take an event source and drive, serving and other things with those events and react to them and whatnot. So that's sort of the origin story. We started with sort of identifying a set of building blocks that we wanted to, that filled gaps that we thought could be composed to try and create traditional serverless-like experiences, but where you could use pieces and not the whole if you wanted to.
Definitely. Yeah, that was something I noticed, because it's a little bit of a, I guess, different style for an open source project to have these two kind of like major components that integrate super well together, but also are developed kind of, at different paces and, have different maturity levels and that sort of thing. I wanted to go ahead and one thing that I like to do is just kind of like look at the docs and ask some questions about the different things it's describing. So I'll go ahead and share my screen here, and we can see some of the stuff y'all have here. So as you see, when you look at the GitHub page for the Knative org, right up here, you have community serving and eventing. So, they are completely separate projects using a lot of the same tooling behind the scenes. And then also in the Knative documentation, it has these high level goals, but as soon as you jump over to the documentation, you'll see the serving and eventing components separately. And I kind of wanted to ask about how you kind of see these used independently. And that's a little more obvious, at least from my perspective, for the serving side of things. That's kind of like your traditional, I want to run a containerized workload on Kubernetes in a serverless fashion. And how do you see eventing both interacting with that as well as kind of being used in isolation with other parts of Kubernetes or, just other container technologies?
Yeah, so that's a great question. So, to step back a little bit, part of the reason we wanted to make sure that folks, that these components were not tightly coupled was, we've seen sort of a lot of past-like things in the past where there are like dozens of really valuable features, right? But there were sort of limitations that sort of boxed you in. And as soon as you grew beyond the limitations in one dimension or another, you had to throw like the whole thing out, right? And so one of the principles that we sort of try to adhere to is, we wanted to be able to not just use these independently, but if you're using them together and at some point you sort of grow beyond the limits of one of them, you can keep using the other pieces, right? And so, an example of this would be if I start with serving because, I'm getting sort of spiky traffic, but I grow to the point where my service has actually pretty predictable traffic, and the scaling aspects of it aren't necessarily buying me as much as it did when I was first getting started. Mm-hmm. If the traffic's being driven by eventing and the event stream has become sort of predictable, I can actually replace my use of serving with Kubernetes deployment if that's what you wanted to use, or whatever the new hotness becomes. But I think the extensibility model that we've developed as part of this, I think, is one of the interesting and sort of hidden gems of Knative. So I think eventing's taken a bit longer to mature, partly because it has been one of the places where we're going to have the most API service because we have, we're going to need a lot of different event sources and things like that. And so we wanted to make sure we got sort of that extensibility model right. But what's cool about it, and you were asking about how you see eventing used in isolation. I think what's interesting to me is the model we've developed for shipping event sources. You can basically adopt the Knative model for an event source, and as we'll talk about later, bindings, and install a source with no dependency on really eventing core or serving, right? And what that enables you to do, I mean, it really reduces the barrier to entry to authoring sources, right? And so we recently released a source for some vSphere events. And so you can actually install that on your cluster with no Knative stuff at all. And if you want to, you can send that to just Kubernetes services and have code reacting to vSphere events without any of Knative installed. You just have this Knative style source.
Right.
But then if I install eventing, I can then start to feed it through things like our broker abstraction. And if I install serving, I can start to actually have the deployment that's receiving those events scale to 0 or scale up if there's a large volume of events. So I think that's some of the way we see it panning out. I think for things like sources, we wanted to make the barrier to sort of shipping sources have 0 runtime dependency on sort of Knative proper. And that means that you can ship things that expose a Knative style source API as part of your product or whatever, right? And so if a user decides they want to use Knative, great, they can use that source with it. But it also works with Kate services and whatnot. So really, it's you don't have to drink the Knative Kool-Aid in order to and your users don't have to drink the Knative Kool-Aid for you to ship these sources and for them to get value out of it, right? But we think that if you install those additional things, right, they complement each other really well, and you can do more powerful, more interesting things. So I said a lot. Does that answer your question?
Yeah, absolutely. I think that's super helpful, and kind of tying that to some of the architectural decisions in Crossplane as well is, we don't have necessarily as separate of 2 projects evolving at the same time, but we have a similar plugin based architecture where we want to make it really easy for you to add new functionality to the ecosystem. And one of the benefits of running things on top of Kubernetes is it allows these things to just kind of speak the same language by default, right? So for instance, when you're running a provider for Crossplane, which is allowing you to interact with some sort of infrastructure or software as a service provider that allows you to provision things, you actually don't have to have the Crossplane control plane present there. You could use that to orchestrate between these different providers and that sort of thing. And it also helps installing and making sure you're not stomping on different CRDs that exist and setting up RBAC correctly and that sort of thing. But they are just Kubernetes controllers, right? So they can kind of run in isolation. And lots of times when we're testing them, we actually do run those in isolation. So I can definitely see the benefit there. One of the first things that comes to mind when we talk about kind of making things more configurable to fit more use cases is there's an inherent tension there, right? With making things more configurable and also making them simple and coherent. So this is a bit of a leading question because in our demos today, we're going to use Mink, which is a tool that you've put together, or a service, I guess, that you've put together, which will make this a little bit easier. But just from a personal perspective, as we try to tackle this in Crossplane as well, what's kind of your philosophy and the team's philosophy about building something that's cohesive and understandable while also making it expose the right knobs for any orchestrators to turn?
Yeah, so this is a funny balance, but I'll sort of give my spin on it, and I think this aligns with sort of how we've been approaching things upstream. So in Knative upstream, right, we want to make sure that the pieces are decoupled, and that folks who just want that one piece can come and take that piece and install it and be successful with that one piece, right?
Right.
we also, have an extensible networking layer where you can install Istio or Glue or Ambassador or Contour or Courier. There's a whole bunch of these networking layers. And the same goes on the eventing side with channels, Kafka-based, in-memory, NATs. There's a whole bunch of different systems there. And so upstream, we try and be, I refer to it as Switzerland, right? We try and be neutral. We try and be sort of unbiased, and we sort of present you with options where, where we have an extensibility layer, you can pick one of those options and run through the instructions and get an install that sets you up with Knative. But you mentioned Mink. Mink is sort of proof of concept that I've been playing with, where it upstream is sort of unopinionated and lays out the components. Mink tries to be a little bit more opinionated and glue together some of the options into something that I think is more sort of readily consumable. And I think of it as sort of a distribution of Knative, if you will, right? Where you've got things like Kubernetes upstream, and then things like K3s, or I know OpenShift's much bigger than just Kubernetes, but OpenShift and so on and so forth. So I sort of think of it as an opinionated bundle of Knative plus stuff. It started as just Knative stuff, but it's grown. And it glues it all together so that you get sort of a relatively complete experience with a relatively simple sort of bootstrap, because a lot of the choices you have to make when we're sort of presenting you with options upstream, it makes some of those choices for you out of the box, at least.
Right.
So yeah.
Yeah, no, that sounds great. And, I pulled up this page on installing, and there's a couple different ways you can go about installing Knative. But even though there is, a lot of different ways to tune and configure it, it's pretty straightforward in terms of the steps you need to take. If you actually ran through all the commands here, I think it's maybe 6 or 7 things you have to do. So I think y'all have done a nice job of allowing that to be configurable, but also when I was creating demos for this live stream, for instance, I installed it. Once again, I was using Mink, which made it a little bit easier, but just playing with some of these things made it pretty simple. So I think y'all have done a nice job there for sure. Before we go further forward, I want to dive a little bit deeper into exactly what composes the kind of like serving component. The eventing component, I think, is really valuable, especially from some of that like decoupling aspects that you talked about earlier. Today, we're going to mostly focus on the serving component, and we're going to be talking about how to consume managed services that are also provisioned through the Kubernetes API in your Knative services. So I want to jump over here, and obviously this is kind of like your wheelhouse as you lead the serving side here, but could you kind of talk about behind the scenes what happens, how a Knative service is different from running a deployment and exposing it with a service using native Kubernetes types?
Yeah, sure. So I think Kubernetes has a lot of really powerful abstractions, like deployment and service and ingress and HPA, right? But you've got to basically compose a whole bunch of things in order to successfully ship an HTTP service in sort of a sane way. And so last summer, I gave a demo where I basically stood up a gRPC service that used, it ran as a deployment. It was exposed through Istio. And I didn't even configure auto scaling or TLS. And I basically gave a demo of migrating that to a Knative service where I just deleted lines and changed the API version in kind and redeployed it. And now I have auto TLS, request-based scaling, scales to 0, scales up, right? And I can do streaming gRPC or unary gRPC calls. And it just works, right? And so the diagram that's on the screen sort of talks about how the resource model decomposes a little bit. It doesn't get all the way down to sort of how we create the Kubernetes resources for you, because in some cases it gets very, very complicated, and I can talk about that. But let's go through the anatomy of this, though, right? So at the top level, the service resource is sort of the one resource to rule them all, if you will. I used to not like it. I really like it in our V1 API. It's all I use anymore. And I'm really happy with where that landed. But service basically marries these two concepts, route and configuration. And so basically, if all you're doing is sort of deploying code and you just want the latest thing to sort of roll out, assuming it works, you should be able to stick with service pretty reliably. The sort of default knobs, it will sort of, if your code boots up and like successfully passes readiness checks, it will roll that out to the rest of your traffic. And so the way that's holding the route in configuration, the route basically acts as a layer where you can configure various forms of traffic splitting. So you can do, so obviously the simple case of just send all of my traffic to the latest thing the configuration has produced is one of the modes, and that's the default the service configures for you. But you can do things like I can pin to specific versions of the configuration that we call revisions, and I can have very fine-grained rollout between them using percentage splits and whatnot. And I can do things like apply tags to particular parts of the split that allow me to address just that part. And so if I wanted to do something like begin to qualify a new version of my code as I begin to roll it out, I can pin that revision by directly referencing it in my traffic block in the route, or it's exposed through the service. I can then send percentages of traffic to that, increasing and taking it away from where the lion's share of the traffic is headed. And but before I do that, I can tag it and send 0% of traffic to it, qualify it using integration tests, functional tests, whatever, against that dedicated endpoint, and then start to shift traffic to that over time. So this was my bonus round of that gRPC thing, right? Because doing percentage-based rollouts on top of Kubernetes deployments, even with Istio, is really hard because Istio can do percentage splits. It's how we started doing percentage splits, but it splits percentage-based over services. So you can do it if you want to stand up a new deployment with a new service and whatnot. And so we manage a lot of those details for you behind the scenes. And so I talked a bit about the route. The configuration is, so I like to think of the configuration and the revision sort of like Git branch. Like the configuration is like a Git branch, and the revisions are kind of like commits, right? And so as you update the configuration, it spits out a new revision, and the configuration tracks the last one it created and the last one that became ready. And the route, if you're running in this just YOLO roll out the latest mode, will track when the configuration sees revisions become ready and roll them out. So, revision readiness. So because we, know we're dealing with, network-based deployments, we basically do some things like you can provide a readiness probe, in which case it won't be ready until you succeed that readiness probe. Or if you, don't bring your own readiness probe, we know enough. We know that you are a network-based service, so we'll make sure that you are at least listening on the right TCP port before we'll roll traffic over. And so if your application's like got a syntax error and crashing and not even coming up and listening to the port, right? We're not going to roll traffic out to it because that would be crazy. And so even in this YOLO like rollout latest mode, you've got some sort of built-in safeguards where we do some simple sanity checking before shifting traffic over.
Yeah, for sure. I actually noticed that when when I started out, for sure. And I think this is an illustration of a good abstraction. I don't have the context for what the service looked like before the V1 API, but personally, I also really like it at the level it's at. It picks a lot of good defaults for you. But when I was doing some of the demos, I was, changing things and pushing new versions really frequently, and noticed that one of them failed, but I was still serving traffic, and it was accepting on the latest or on the last one before the broken one. And so you just kind of get that sort of stuff out of the box, which is definitely a huge benefit. So I personally, without even knowing initially about the revisions and that sort of thing, just enjoyed deploying a service. Felt like deploying a pod or a deployment to me personally. So I think it's a really nice onboarding kind of step for folks that are familiar with Kubernetes style APIs, but maybe have not even ventured in to serverless type stuff.
Yes.
Go ahead.
Yeah, I was just gonna say, so one of the things we did in the V1 API, configuration and route chain each changed a little, and service was fairly different before, and we basically made it align with where configuration and route sort of landed, but it sort of blended. But one of the key things we did, changing sort of the configuration spec that we inline into the service was we really wanted to lean into the sort of familiarity with that common shape that you see across all of the Kubernetes application resources, right? And we'll get more, we'll touch more on this topic, I think, when we start to talk about bindings, right? But if you look across all of the Kubernetes application resources, job, deployment, replica set, stateful set, daemon set, every single one of them embeds a pod spec in the same way. And so even though I think to this day, right, we're working on allowing multiple containers, the way we embedded the single container we allowed was by adhering to that shape, and then basically leveraging validation to say, oh, we don't allow, these things, or we don't allow these things, which actually is pretty similar to how all of those other application resources embed things as well, right? So if you look at a Kubernetes job, it embeds a pod spec the same way as a deployment. But a deployment, you have to use like restart policy always, right? And in a job, you can't use always. You have to use, on failure or never, right? And so you end up with the same shape, but different sort of policies around how you validate that shape. And so so we sort of went out of our way to sort of adhere to that shape, and then leverage validation to sort of say, okay, well, within this shape, here's what we support. And we suspected at that time that we would be able to do some of the cool things that, we're going to talk about with bindings. But that was, still pretty, it was still vaporware at that point, I'll say that.
Right. That's understandable. And as you mentioned that, we're definitely going to get into talking about some of these bindings things. And that's something I think that is one of the best things to talk about when we're talking about both Crossplane and Knative. So to kind of motivate some of that discussion, since we're about halfway through here, I'm going to go ahead and move into some of the demos we have. So they're going to be pretty simple demos. Basically, we're going to show you deploying a Knative service that's consuming a Cloud SQL database, a Postgres database that's provisioned with Crossplane, kind of show you how you can wire that up using Kubernetes secrets. And then the second demo is going to be almost exactly the same. It's going to be running the same image in the Knative service, but we're going to use a binding instead to wire up that secret. And these are very simple examples for how complex you can get with the Knative ecosystem as well as with Crossplane. But I think they're a good jumping off point to talk about some other things. So I mentioned earlier that to get set up here, we're going to be using Mink. I'm going to run this on a GKE cluster so that y'all can go to the URL when it's up and kind of see it running, and actually maybe we may regret actually making it possible for you to post things there too, but we'll see. I trust that everyone here is an upstanding human being, but we'll see. So anyway, installing Mink is really simple. As you'll see, I'm going to apply one file here. And if you actually look into this, it's a rather large file, but basically it's making a lot of different opinionated decisions for you about things you want to include. And it's bundling a lot of different things together. So I kind of look at it as, if you want the whole Knative experience, here you go. And we're going to make it work for you out of the box. It also kind of like makes it a little bit less configurable and that sort of thing, because it is choosing these defaults for you. But when you're running something like a demo, or maybe you're just getting started within your organization, I think it is a really good way to go. Before we do that, I want to also just point out the GitHub repo for this so that folks can see it. It is at Matt Moore Mink. So if you go here, it's pretty simple. The easiest way to get started, after I fumbled around with it a little bit and sent Matt some messages, the definitely easiest way to get started is just going to the assets here and downloading release.yaml. That's exactly what I am applying in this demo. You'll also see that, and all of these manifests per usual will be available in the TBS repo. I've also got this Mink local one here, which is from playing around with running this in a kind cluster. So if you want to run this on your local machine, this should set it up with exposing it as a node port, so you can access it at your local server. So there's also some docs in there about that. So to get started here, we will go to the guide, and I'll get started with installing Mink. So let's see what we have here in our cluster so far. Just the GKE default things. So let's install Mink. And I should probably get in the right directory to do that. All right, so we're going to see a number of different things going by here. And Matt, I'll definitely get you to comment on some of the defaults that you're using here. It is a little bit hard for us to track everything that's going as it's scrolling by the screen. But what are some of the different components, especially things that are more configurable sides of it? So outside of just the core serving and eventing stuff that you're choosing here as good defaults for getting started with Knative.
Yeah, so let's see. So this includes most of serving and eventing. I think it includes almost all of serving, and right now it includes most of eventing too. It doesn't include, I think, the flow stuff, the parallel and sequence resources. But it also includes Tecton, which uses the same sort of controller infrastructure that we're using. And it includes Contour, which is an Envoy-based ingress controller that I think just landed in the CNCF. Let's see. And so let's see. So ingress, it chooses Contour. For eventing for the broker, assuming you grab the .14 release of Mink, which aligns with the Knative .14 release, it uses this new multi-tenant broker. It used to be that the broker that was run would create some pods in every namespace where you enabled it, which doesn't feel very serverless. And so the multi-tenant broker runs a shared component, sort of like serving does, to make it so that the footprint per broker is effectively 0. And so with that, we can sort of pre-create one for each of the namespaces. You can just start to use the eventing model without having to learn as many concepts. So another thing that this is doing is there are a bunch of sort of POC bindings that it includes. It includes a handful of sources. It includes, let's see, the GitHub source. I use this to run all of the bots that run over the Knative repos, automated code reviews, and it runs some daily builds to do automated code cleanup. Let's see, so it uses the GitHub source for listening to GitHub events. It is using things like some POC GitHub bindings and whatnot to authenticate with the GitHub API. And then we linked in linked in the VMware sources that we just released in .14 because we were using this for an internal hackathon last week. I think it was last week, yeah. And then one more thing on the serving side, this actually enables auto TLS by default. And so we shipped a simple HTTP 01 challenge controller in .13, I think was the first release that came out. Maybe it was .14. Basically, all you have to do is configure a domain pointing at the IP that's set up. That's not the xip.io thing because there's no way that works with Let's Encrypt HTTP challenges. And you'll be able to actually get TLS terminated services within, I've had it working in just a couple minutes from fresh cluster to Mink installed plus, DNS configured. Actually, DNS ends up being one of the long poles, depending on the expiration period you've configured for your records. So it's intended to be a very streamlined install of serving, eventing, Contour, HTTP 01. I think this is using the in-memory controller. You can tease those apart and use something like the Kafka-based channel. But yeah, those are sort of the things you get out of the box.
For sure. You mentioned a little bit, and we're going to use that today, this kind of like xip.io. Magic DNS here. Will you talk a little bit about what's happening with that? And while you're doing that, since folks are probably familiar, I'm going to go ahead and install Crossplane and provider GCP, as well as get my credentials set up. So this is something we do on almost every episode. Today, you'll see I'm going to be using the alpha Crossplane, which is the 0.10 version, which was released very late on Wednesday night, as me and Nick were trying to finish it up. And also the newest version of provider GCP here. So we're going to bring that along as a single package. So while Matt's talking a little bit about how DNS works here, I'm going to go ahead and install Crossplane, configure GCP, and I might move into setting up some of our classes and claims and that sort of thing.
Yeah, so let's see. So basically, in serving, what we do is, sort of like Kubernetes services give you that service name .namespace.svc.cluster.local. If you're referencing them within the cluster, those DNS names are set up for you with kubedns or core DNS, whatever you're running. We wanted to create a similar sort of host-based dispatch for Knative serving. So when you create a Knative service by default, there's a domain that's configured with the cluster, and by default, it's just going to use example.com, right? And when you create a service, it's going to create your Knative service name .namespace.example.com. So there are these cool services. xip.io is one, nip.io is another. They're not super reliable, so definitely not for production, but it's actually pretty useful so that you don't have to find your IP and then curl with a host header to the IP. And so what it does, and this is another thing that Mink is sort of bundling for you out of the box, we have this job, Kubernetes job that runs when you apply the YAML that basically figures out the IP for the ingress that you have exposed. And if you are using something that it gets exposed as IPv4, xip.io and nip.io, those basically have this magic DNS service where if you have IPv4 address.xip.io, they will serve a wildcard A record for you. And one of the cool things about this is this even works if you're using it with IP addresses that aren't necessarily exposed publicly, or 1.7.0.0.1 works, right? It will return the IP of that you've embedded in the domain. And so what this lets us do is set up a sort of working out of the box domain name for IPv4 exposed clusters, where you get service.namespace.ipv4.xip.io. And that's hideous and ugly, but at least the URL that shows up when you list your Knative services is clickable, right? You don't have to jump through hoops in order to access it. But I mentioned how that doesn't work with Let's Encrypt and HTTP/01 challenges. One of the gotchas with HTTP/01 challenges, and is a fair warning for folks playing with this, I hit this all the time developing it, is if you use the Let's Encrypt production environment, which actually uses CA cert signed certificates, it's pretty easy to exhaust your certificate quota for a domain if you use HTTP/01 challenges. You get like 50 challenges per week, I think, and it's per sort of registered domain. So if I were using, say, mink.dev, which I was surprised it was available and I bought it, you would basically be able to, regardless of how many prefixes you put on that, you would be able to basically issue 50 certificates per week, I think, under that domain. And so it's a pretty reasonable number, and the certificates last, I think, a couple months. But for something like xip.io, where tons of people are using this for development, it is unlikely that you're going to actually successfully get through one of these HTTP challenges. Although, yeah.
Well, I appreciate you giving that. We're actually going to use xip.io for this today, just because it kind of comes out of the box. So it's really nice, and we'll share that URL with folks. As you saw there, despite my kind of flaky connection with GKE right now, I was able to install Crossplane and provider GCP, and we saw those pods come up and running. So it's now watching for our GCP types, and those CRDs are installed in our cluster. We're going to go with our normal approach here of dynamic provisioning. So we're going to set up a class here, a Cloud SQL instance class. And as you'll see in the for provider section here, it's going to have some things that allow us to create a Postgres database. And we're just going to open that up to the world. And then it's going to propagate our connection information into a secret. And we're going to write that to the Crossplane system namespace. And then it'll also be propagated to the namespace where we claim it. So we'll go along with this. And we've done this on a few other episodes, so you may be familiar. So I'll go ahead and create the class. And when we create this class, the CR gets created in the cluster, but nothing's happening yet. We're just saying at a future date, we want to use this configuration to be able to spin up new Cloud SQL instances dynamically. So to be able to actually use that, we're going to create a generic Postgres claim for this. So if you look at the Postgres claim, you'll see that it doesn't have anything specific about GCP. It is selecting that class using labels. If we didn't provide labels, it would pick one at random in our cluster. So this could be different size Cloud SQL classes, or it could be a database on AWS or Azure or Alibaba or something like that. So we can dynamically provision and kind of define our own schema here in the labels to be able to choose which kind of class is going to be selected here. I also want to note, and we'll mention this a little bit at the end of the show, and we'll have some more shows coming up on this. We have brought in experimental support for some new types of classes, essentially. That's part of our composition effort, which is basically going to allow you to bring together multiple classes and claim them as one solid unit, and then render out those managed services from that. So essentially, this process is just going to be getting a lot easier for folks and a lot more customizable. So stay tuned for that. So we've now created this Postgres claim in the default namespace. So if we look at the claims, this is also something new we added, which isn't really that unique, but we added categories to all of our CRDs for this release. So you should be able to get things by just claim or class or the provider they are. So you'll see that our claim exists. It bound to that class. And we see that a Cloud SQL instance is being created, bringing together the claim information and the class information and actually creating a Cloud SQL instance on GCP. And so if we then see what GCP resources we have here, we should see, as you'll see here, that we have that Cloud SQL instance class and the provider that allows us to connect with GCP. You also see that we actually have a Cloud SQL instance that is pending create right now. So over on GCP, that's getting provisioned, it does take a little bit of time to come up. So while that's happening and the secret is getting written, I will go ahead and move over to looking at what our service is going to look like. So as I mentioned earlier, this looks super similar to a deployment or a pod. You're going to see this same containers stanza here, which is actually the exact same as what's in a Kubernetes pod spec, I believe. And we're going to be using this TBS 15 service, which is a really simple Go application here, which is basically going to connect to a database and serve up a welcome page, as well as a create endpoint that allows you to just submit data to it, which will open up later on, and also list what's been submitted already. So really simple service here. But a lot of times getting something like this running with, TLS termination and that sort of thing can take actually a significant amount of effort despite its simplicity. So we're going to show how that's a little bit easier using Knative. And once again, Matt, as I'm walking through this, please feel free to jump in and say, hey, this is what's happening here. When we create the service, I'm going to poke around and kind of take a look at, what pods exist, where the K services are, and that sort of thing. So feel free to jump in for any part of that. I'll start off, even though this has already been pushed, we'll go ahead and build and push it again just to show the full workflow here.
Check out Co.
What did you say?
I'm going to shamelessly plug a tool called KO, which we use religiously across most of Knative. It's pretty nice.
I was taking a look at it. I think I messaged you. I was trying to get it to use it to install Mink, which I've never used Co before. But I was just kind of reading about it, and it seems pretty powerful and makes it a lot simpler to do a lot of things. So we might have to have a special episode on using that.
Yeah, it's fun. It's github.com, Google Co. Basically, I think the main problem with using it with Mink right now is we've been shifting over to Go modules, and I haven't bitten the bullet and done that downstream in Mink yet. But yeah, if you use it on GoPath, it should work all right with Mink. But yeah, and I think something that I think surprises a lot of folks with Co is you don't have to install Docker anymore. I don't have Docker on my MacBook at all anymore. It just does cross compiles of the Go code, and then it containerizes things by stitching together the image against the registry API and publishes it like magic.
For sure. Okay, so it looks like our Cloud SQL instance here is runnable now, which is kind of GCP's way of saying that it is ready for use. You'll also see that as we were watching this, the status went from no status to unbound to bound. So this is kind of related to some of the binding stuff we're going to talk about in a minute. This is one of the ways that we bind resources together in Crossplane. As I mentioned, we have claims and then classes and managed resources. So a claim has a one-to-one binding relationship with a managed resource. And so in this case, since we dynamically provisioned this managed resource using a claim, then it's automatically going to be bound to that claim when it becomes runnable. And what that means is it's basically going to say wherever this claim exists, which is namespace scoped CR, as opposed to managed resources being cluster scope, it's saying we're going to basically provide connection information there so you can wire up your Knative services or your deployment or whatever you have there to be able to talk to this database. So it's basically a claim for usage of a managed resource. Similarly, if you create a managed resource directly, so if instead of using a Cloud SQL class here and we had just gone ahead and authored a Cloud SQL instance directly, that would just be unbound and waiting for something to pick it up and say, I'm going to use this and consume it in this namespace. So if we look for the secrets in the default namespace, we should see this con secret here, which is all of our connection information. You'll see Cloud SQL actually gives us quite a lot of connection information. And because the Knative services look so similar to deployments and pods and that sort of thing, we can do a similar pattern of just providing this from the secret, this connection information, as environment variables in the service. So for the first example here, we are actually going to explicitly reference the secret with the secret key ref, pull those values in, and use it to connect to the database. So I'll go ahead and create this service. And as I do that, Matt, do you want to talk a little bit about what's happening behind the scenes here?
Sure. So if you just watch the get K service, basically the K service is an alias for that service resource because we unfortunately decided to do name collision with Kubernetes. Basically, it created that route and configuration resource, and the configuration resource spat out the first revision. The revision created a deployment and a service and some other supporting stuff. And basically, it booted the container to the point of a successful readiness probe. Since you didn't specify one, it basically waited till it could connect to your container via TCP. And then it reported everything back up ready. The route then observed that. It programmed the ingress and then probed it until it actually saw that the networking layer was probed. And so by the time this K service actually reported ready true, like we have verified your network connection hitting your service from the sort of edge envoys all the way through to your service. And if you wait too long, this is going to scale to 0.
Yeah, I wanted to mention that because actually the first time, you'll see here it's terminating actually already. The first time I provisioned this, I had no idea what was happening behind the scenes, and I was like, well, there has to be a pod running somewhere. And I got the pods, and I was like, how is this even working? This really is magic. But you'll see here that it is scaling to 0. But if we try and access it, it's going to scale back up and serve for us. So do you want to talk about kind of how it does that, as well as how you make sure that there's not a lot of latency when it scales to 0 and you have what could be a cold start there?
Yeah, so yeah, so in terms of how it works, when we think your service is sort of under provisioned and 0 is a really easy case for us to know, hey, there's probably not enough pods. We actually hook something into the data path in front of your container called the Activator, which is a sort of load balancer that's aware of what's going on. And so what it does is it basically parks open requests and sends metrics to our autoscaler saying, hey, I need, I have requests for this revision. Can you wake it up? And we scale things back up. And then when that data plane component observes that the pods are ready, it basically forwards the traffic on. And so this gets into some of the sort of details of how we do some of the stuff with the underlying Kubernetes components, but we actually, we may run N activators, if you're on a cluster with, where you want to be provisioned for running a lot of Knative services. We actually pick, we will in our next release pick a subset of those that we think is the right amount for the amount of traffic your service might get to put into the sort of endpoints resource that sits behind Kubernetes services. And when your service is, so what we try and do is we try and provision ahead a little bit. We have these models around sort of tracking capacity. And basically, we try and give you a little bit of, there's a whole bunch of knobs for this, but we try and give you a certain amount of headroom and provision ahead so that instead of you hitting cold starts every time you add a little bit of capacity, you have some wiggle room. And so, we provision ahead by something like, I think 30% in terms of us anticipating how many more requests per second you're provisioned for versus what you can handle. And that, I think, has been the way we've avoided cold starts the most. I mean, the cheapest way to deal with a cold start is to avoid them completely, right? And so, outside of bursts of a certain size, we try and provision ahead so that if you're gradually adding capacity, you'll never really cold start because we're sort of provisioning ahead, right? And so if you have a huge burst though, the point of the activator, and the reason we keep it in even when it's not scaled to 0, is it, it's this better provisioned pool of things that running on your cluster that can act as sort of a meat shield for your services and be like, hold on, I'm waiting for that guy to spin up more capacity. We're not ready for you yet. And so we try and do that. The activator is also sort of a very specialized load balancer. So a lot of sort of fast-like experiences in the serverless space allow you to limit the concurrency of requests that are hitting your container. And so like Lambda, for instance, only lets a single request through to a running instance at a given time. And so you can do that with Knative by setting container concurrency. And when we started, we just did probabilistic load balancing, and we run a sidecar that basically buffers requests if you get more than you're configured to handle. One of our working group leads, Victor, has done a ton of great work, doing sort of aware load balancing in the activator so that you actually get better performance these days by having the activator there than by not having it there, because it is actually so good at load balancing in the presence of this container concurrency field. And we do a whole bunch of tricks to make that happen. And so, yeah, our numbers with container concurrency 1 these days, I'm very happy with. And it used to be I was not happy with, though.
Yeah. Well, we appreciate the transparency there. So it looks like that our service is now up here. You'll see you can go to this URL yourself. I'll drop it in the chat right now. So you'll see that we just have this nice welcome page. But this doesn't show us if we're connected to the database or not. We should be able to list things and see that it actually is able to talk to the database and see that there's nothing currently in the database. So you'll see nothing showing up here. So let's go ahead and actually put something in the database. So basically the schema here is just reporting yourself as a viewer of this stream. So I'm putting myself, my location, as well as my Twitter here. You'll see I'm posting this to the create endpoint. So like I said, you're welcome to do this at home. Please do not put anything profane in this demo, or we will have to stop for the rest of the day. All right, so now when we go to the list endpoint, we should see that here I'm popping up. So right, we're able to write and read from the Cloud SQL database here. So if anyone wants to drop their information in and let us know they're joining, feel free. I will give some shout outs to some more folks that have joined while we're doing this. It looks like Nathan Thomas, who's been over in Crossplane Slack, has joined. Thanks for joining. Harishi from Bangalore, thanks for joining. Sahil from India. Both of them have been contributing quite a bit to Crossplane lately, so we appreciate you showing up. And Jan from Berlin, also on the call. We appreciate you tuning in, especially because I assume that it's a bit later in the day for you folks. So we appreciate you tuning in as you get ready for your weekend. Let's see if anyone else has posted anything here. It doesn't look like it. Matt, if I send over a link to you, you want to drop your info
I'm just typing in the URL. Alt tab,
okay.
alt tab, alt tab. Let's see. All right, you should have a new one.
All right, looks like it. Let's make sure our link works. Everyone can go follow Matt on Twitter now. That's actually the purpose of this demo, just to get us all a bunch of followers. So hidden motives here. All right, so if anyone wants to drop stuff in there, we'll keep this open for a bit longer. But the next thing I want to show is we obviously kind of like specified where we wanted the secret written and then explicitly reference that in our service, which is kind of fine if we're owning both sides of that process. And it makes it a little bit simpler. And if we're using infrastructure specifically for this single app or this single function that we're running. But now one of the things we alluded to earlier is binding. So there's a lot of different ways that services bind to each other across the Kubernetes ecosystem. But I want to specifically talk about some of the work that Matt and some other folks, my computer will unfreeze here, have done on the, let's see here. Looks like I'm having some troubles. Have done on bindings in Knative. And we're also going to do a demo here of them. So I would encourage folks to go over and take a look at this bindings repo. We're actually going to use one of these, which I believe you said is a newer one, the SQL binding here. So these are basically a set of bindings that allow you to inject connection information into services or deployments, et cetera, from different information sources. So you'll see things like a GitHub binding, a Slack binding, Twitter, et cetera. We're going to be using the SQL one. There's actually one specifically for Cloud SQL as well, but we are going to use SQL here. So you'll see that you specify a subject and then the secret. And then using things like labels, it's going to automatically, when services are created that satisfy this match labels, it's going to inject those as a volume mount in the container, and we'll be able to access it. This one does specify that the information is provided in this connection string field. So I'm going to actually mutate the secret we wrote a little bit to be able to use it, which is another conversation that's happening about how we can kind of like standardize and move towards a general representation of bindings in the Kubernetes ecosystem so that things like this are just really seamless. But for today, I will go ahead and modify our secret a little bit. So basically, I'm just pulling these fields off of the secret that was written by Crossplane for the Cloud SQL instance, and I'm going to combine them together here and create a new secret specifically for this binding here.
Yeah, so if folks want to get involved in that conversation around bindings, we created a channel in the upstream Kubernetes Slack. I think it's Bindings Discuss. Mm-hmm. So, join us.
I think Mocha, who is running the tweets for today, is actually going to mention that on one of the tweets we're putting out there. So hopefully some people will see that and be able to jump in there. So as you'll see here, we just created another secret. This one's called conbind. So let's make sure that it is present here in our namespace. So we'll see we have the conbind secret here. It just has this one field in it. And if we look at the service we're going to use, once again, we're using the same exact image. I wrote this basically to take either one of them. So first it's going to look and see if that volume has been mounted, if that file is available. It's going to use that to connect. If not, then it's going to fall back on using these environment variables. So in our first example here, we use the service with environment variables. You'll see this one here. The application developer, the person deploying the application, doesn't actually have to be aware of the secret that exists. It's basically saying maybe in this namespace, for instance, or things with these labels, we want to always provide that connection information, and they'll just kind of be able to get that out of the box. So when they're writing their application, they can have a consistent way that's available. It's especially useful. I think I mentioned this Cloud SQL example earlier, but when you're using libraries that kind of have this chain of authentication, I think it's especially useful where it's doing things like setting an environment variable that it falls back on, so that, basically they're saying, when I deploy this, I'm just going to assume that I'm going to be able to authenticate with it, and it'll kind of magically, if you will, be provided there.
Yeah, so this is similar in some ways to, Knative has this sort of sibling in Google land called Cloud Run, which it doesn't run on Kubernetes, it runs on Google's serverless platform. And one of the things it does is it integrates with Cloud SQL in a way where you basically can augment the runtime environment for the container with like a mechanism that like hooks you up to Cloud SQL so that you can talk to it, right, without having to do a whole bunch of configuration and juggling authentication and whatnot. And so the binding in the context of something like this is also intending to help with, get a similar experience, right? Where the goal is, as an application writer, I just sort of anticipate that the environment I'm deploying into sort of has been extended with, a way of talking to Cloud SQL and, using some libraries to just sort of talk to it. So if you're used to writing Kubernetes controllers, the example I like to give, that I think parallels this in a really interesting way in Kubernetes is the way the containers file system is augmented with like a service account token and endpoint information so that you can reach back out to the Kubernetes master when you're running in the context of Kubernetes, right? That just sort of, Kubernetes magically extends the environment with that service account information. And so the way I sort of think about bindings is they're constructs that augment that runtime environment in some interesting way. And so if we can sort of standardize on some of those mechanisms for certain classes of application, like MySQL or Postgres or, Kafka or GitHub, et cetera, then, we end up in a situation where folks can do this, write portable apps that can then be bound to that contract, across a wide variety of contexts, cloud providers, et cetera. So anyways, that's
Definitely.
how I think.
Yeah, I think that's a great point. And one of the things, if y'all do join that Binding Discuss channel, one of the things that Matt and I were talking about recently in there is kind of like being able to standardize on formats for secrets and how they're consumed. So one of those ways, as Matt pointed out there, was kind of just going with whatever the idiomatic way is for whatever you're connecting to. There's also been some discussion about the ability to kind of like transform secret values or connection information to your liking. So once again, if that's something else you have interest in or your project's doing something similar to that, feel free to jump in there and chat with us about that. So I did, while Matt was talking, go ahead and create that SQL binding that has the label selector on it for, I believe it's called bind SQL here. So now we're going to create this service bind here that has that bind SQL label on it. So we should expect for that information to automatically be injected into the file system and be able to access it. So let's give that a try.
Yeah, so this is actually a source that Vilay put together. He's one of the other founders of Knative and leads the eventing side of the world. We were doing this hackathon recently, internal to VMware, and we wanted to play with Postgres. So he put this together because we weren't using Cloud SQL, and he wanted to be able to talk to some internal Postgres stuff. So
awesome. Right. So it looks like that our new service is up and running. You'll see we're on the homepage. So we once again should be able to talk to the database, kind of using a different method of getting that connection information. So you'll see here once again at this service, which I can drop this in the chat as well. You can also get the same information. So basically we just provide it via bindings instead of explicitly referencing the secret for environment variables. So
one other thing about the way this is doing bindings, if you switch back to your command prompt and let's see, so can you say kube control get kservice TBS live bind, and if you grab the YAML and probably pipe it to less because it may be big, yeah, at the status it's kind of big. One of the things we're doing is with this style of binding is we run both a controller and a webhook. So as you applied it, we actually augmented the pod spec with the SQL binding volume that points at that secret and the volume mount. So you can actually see what it's changing here, as well as a whole bunch of other defaulting that Knative's doing. But this is one of the key things that allows us to work with, for instance, Kubernetes jobs, which if you just run a controller, you're stuck. You can't use Kubernetes use this with Kubernetes jobs because Kubernetes jobs are immutable. So once they've been committed to the API server, they can't be changed, right? And so if you wanted to inject credentials into a Kubernetes job in order to authenticate with the SQL database here, then you have to do it via the webhook. And I think Vile was using this as part of our hackathon to do things like initialize the database with a certain schema and stuff like that. And he didn't have to think about authentication anymore. He just used the binding and things just worked. So I just wanted to sort of point that out. You can actually see what it's doing to your service.
Right. Yeah, and that's a super cool aspect of it. One thing that I wanted to ask you about specifically is, so you have kind of this like layer that's augmenting what you submit, so that there's a difference between what you submit and how it gets rendered out. So you can imagine if you then modify the thing that you submitted, there's kind of like this layer that it's flowing through. In this case, the binding, which is taking actions. Specifically in Crossplane, as we've moved towards this composition idea, we have claims that are basically user defined, where you're saying these fields can be defined at the claim level, and those will flow through kind of through this template, which instructs it how to modify the resource it's rendered. So kind of how the binding is what instructs how to modify the deployment in this case, or the K service. So what is your approach to if the binding changes in this case? So if the secret reference is updated, or I'm not familiar with all the fields that you can put on a binding to instruct it to mutate deployments as they're being created and that sort of thing. But what's kind of your thought process on that?
So that's a fantastic question. And it sort of touches on a pet peeve of mine around like the use of pods as the point of injection for things like, Istio does this for sidecars. I think a lot of injection at that level, it bypasses sort of high level rollout semantics, right? So you can't do things like gracefully roll out a change to the Envoy proxy that Istio is using, or if you wanted to, so if you use the Cloud SQL binding, it injects the Cloud SQL sidecar as the thing you talk through to reach MySQL, right? Suppose you want to service that. You want to interact with the application at sort of the level of abstraction that like adheres to its rollout properties. And so we use the fact that we have that same shape as deployment and job and whatnot to not just register mutating webhooks where we can synthesize a patch to be applied to all of them in a uniform way, but we also run controller, where if the information we're binding in, this obviously only works for mutable contexts, because I just said it doesn't work for jobs. But if we were to say have a new Cloud SQL sidecar, right? The binding can basically patch an update to your Knative service or your deployment or your daemon set or your stateful set, and trigger a rollout that sort of adheres to what you've configured on those things. Right. So in the case of Knative, if you were to patch in a new sidecar for the Cloud SQL proxy, I'm fast forwarding to a day when we actually support multiple containers in Knative, but if you were to patch in a new container there, you would trigger a new revision. So, and if you are using the YOLO latest mode, it would roll out. But if you don't want YOLO mode, then it would stage a new revision that you could roll out, when you're comfortable to qualify a new release. So, and again, these are all subject to the sort of safety checks of that higher level thing. So if you're using a Knative service, right, it has to become ready, which means it needs to have succeeded a readiness probe. And so if you're doing things like connecting to the database and you can't connect before you respond as healthy in your readiness check, if that sidecar breaks that, right, we won't roll it out, even in YOLO mode, right? Or if you're doing this in the context of a deployment with the same sort of setup, readiness checks and whatnot, your rolling update will be naturally sort of halted by that bad update, right? So so by interacting with it at that level, you get the nice properties of that level, right? Their rollout semantics and whatnot. We've been burned a lot by interacting with things and injecting things in the sort of context and sensitive way that pods pods don't give you a lot of context around like, oh, is this supposed to like run to completion or run for a very, very, very long time? And so one of the things that you find is like when there's an Envoy vulnerability, people are like, well, I got to delete every pod on my cluster. Great. And let it get re-injected, right? And so if we were doing, say, Istio sidecar injection at the level of deployment, what would happen is, rollouts would be triggered that gracefully shift your traffic over to that new proxy, which sounds, I don't know, to me it sounds just about right. But yeah, so, and one of the things that I think is sort of interesting about that is if I, as an operator, am updating some of those configurations, like which Cloud SQL sidecar I want it to be injecting, or which Envoy in the case of Istio, right? I'm still subject to sort of the best practices around rollout for how those applications are shipped, right? And so it's no longer, right, when the ops folks change some global setting, immediate global outage across your cluster, right? Because a lot of those things have to then propagate through a rollout mechanism that has safeguards and whatnot, not just for developers anymore. So.
Right, exactly. I think that's similar to the approach that we're thinking as well, in terms of kind of like setting policies on whether at the higher level setting a policy, whether you want to like adhere to an update for essentially the recipe that is dictating how your thing gets generated out in the end. And then, that allows you to kind of do bulk updates to lots of services, but also not break things when you're moving that intermediate layer. So it sounds pretty similar. Well, we are pretty far over our usual time here, but this has been a great conversation. I do want to wrap it up, as I imagine folks have some things to finish up before the weekend. But Matt, we really appreciate you joining this week. This has been an awesome episode. I've enjoyed kind of like seeing, generally we talk about how things relate from kind of like an end user consumption perspective. So how the projects integrate if you're using both of them. But this was kind of a cool episode because we have this context about talking about actually architectural decisions behind them that kind of are meta for the Kubernetes community, where there's lots of different projects that both the builders of this project and the consumers of it, I think, can benefit from some of the things we talked about today. And as you mentioned, I would really encourage people to get involved in that discussion. We're having on Kubernetes Slack, and feel free to weigh in. I think this is an exciting space that a lot of people are trying to solve here. So a more diverse set of perspectives leads to better outcomes. So we'd love for you to join.
Yeah, thanks for having me.
Yeah, for sure. Is there anything you wanted to finish up with? I usually give folks kind of an opportunity to just riff on anything they want. But if not, then we'll get you back to the rest of your Friday.
I don't have a SoundCloud link, so I think we can wrap things up there. Yeah, if folks want to hit me up on Twitter or Knative Slack, Kubernetes Slack, feel free to bother me with questions.
Awesome. Well, we appreciate it, Matt. And for those of you who are tuning in for an update on the Crossplane 0.10 release, we'll have some additional content coming on that. We're going to go ahead and wrap up this show now for today. But we appreciate you all joining, and hope everyone has a safe and restful weekend. Have a good one, Matt.